So there are two discontinuities that we've talked about so far, a whole and a vertical asymptote. And then the next discontinuity to look at is a horizontal asymptote, which is on the next part of this activity. And the way that we find that is a little bit different. This is looking at what happens as x approaches infinity. So let's look at the horizontal lines, the cases of any horizontal lines that would be a discontinuity and present themselves as a horizontal asymptote. There are three different cases, and the first case is when the degree of the denominator, of the numerator is less than the degree of the denominator. So the first question you would ask yourself when you're trying to determine, is there a horizontal asymptote? Is there a horizontal asymptote? Well, are there horizontal asymptotes? The first question you would ask yourself is the degree of the numerator less than the degree of the denominator? And if it is, the horizontal asymptote is automatically the line y equals 0. So you see here in this example, the degree of the numerator is less than the degree of the denominator. 2 is less than 3. So therefore, there's a horizontal asymptote at y equals 0. So then the other case would be the degree of the numerator is greater than the degree of the denominator. And we see that here in this next example, that 5 is greater than 3, 5 is greater than 3, and so automatically if the degree is greater in the numerator than the denominator, then there is no horizontal asymptote. No horizontal asymptote is present. 5 is greater than 3, therefore there is none. And so the third case would be, we've got less than, we've got greater than, so then we would have equal to. So let's look at when the degree of the numerator is equal to the degree of the denominator. And we see here that the two degrees are equal, and it turns out that the horizontal asymptote is the ratio of the coefficients, of the leading coefficients. So it's y equals the ratio of the leading coefficients. The leading coefficients, of course, have the degrees within the highest exponents. So 2 equals 2, which means we would take the ratio of the leading coefficients, and that's where the horizontal asymptote is. So the horizontal asymptote is at y equals 4/5.